Everyone. Welcome to the first week of our data merging course. This week, we're just going to go over the fundamentals of loading files into R and manipulating data where necessary and everything that we need to set us up to actually perform data merges or joins. You'll hear both terms throughout the course, but this is really just a foundational step and just the beginning of the 3 weeks. Hopefully this lecture works. I tried, previously through Studio to download this and it sounded like I was underwater. So hopefully this is good to go. So what is data merging? Data merging is defined as, I found this online, the process of combining two or more data sets into a single data set. Pretty straightforward. Oftentimes, you're presented with multiple files in different places on your computer, or some may even be available online, and you want to get all this data and provide a homogeneous data set where you have multiple different data points from different files. And here we have an example using patient details and appointment details, and adding those two together or merging them together, joining, gives you this analysis set, which is, it has columns over here for the aggregates from the appointment details table and the demographic information of the patients. So this is the grunt of it of why do we want to merge data? And it's to get a good analysis set to manipulate for whatever task it may be. So how do we merge data? There are plenty of different tools out there to merge data. Excel is probably the most common. The VLOOKUP function is technically a function of merging data from one sheet to another. I'm sure we've probably all encountered or are familiar with. But for this course, we're going to use R. Python and is another good platform to do this on, and there are plenty of others: Tableau, Alteryx, and SQL servers given. So there's a lot out there, but we're just going to focus on R for this course. And so where do we get started? We have to get the data first. So, traditionally, people navigate through their computers using the different folders on their desktop or in their documents folder. And that leads you ultimately to whatever file you want to, use to access and merge with other files. And so in a programming language, we can't obviously click around in folders and say, hey, we want this or we want that. So we have to, be familiar with navigating through our directories or paths, through our computer. And it's very important, and it's the first step in, being familiar with a programming language, in general, but, specifically with getting the data you need to merge. And so we're going to do this through these paths, and they look like this here. It's unfortunately different for Mac and Windows, but it's only the beginning part. Everything else is pretty much the same. It's just basically saying, hey, this user on this computer, this user account, and wherever the file may be stored. So in this example, we're using a teaching and learning folder that is in a folder called JeffDoc, when that folder is stored on your desktop. So, we're going to go from the beginning, and this user, this account, their desktop, this JeffDoc folder on their desktop, and ultimately this teaching and learning folder. The only difference, between Windows is just starting with this C drive thing here. And these are case sensitive and space sensitive, so always make sure that everything's spelled out, exactly the same. And here's just a quirky, dorky little meme of, traditional navigating through your computer, using your icons and lists and all that, and clicking through an opening. That's no bueno here. We're just going to set everything through our programming language and, call it good and move forward with our day. And so the working directory is a very important part of all this. So your working directory is going to be where your programming interface, in this case R, where R is looking for this data. So we're going to have to figure out where R is currently operating out of, what folder it's currently operating out of, and then from there, if it's not the correct folder, we want to set that folder to the correct folder. So we're going to check our working directory through this little function. No arguments are needed. You can just run this and it'll say, hey, this is R will tell you where it's operating out of and where it thinks it should be. And you can access those files right then and there. But if it's not the appropriate folder, you're going to have to set the working directory to whatever folder you want to be operating out of. So here we're going to set the working directory on a Mac, let's say, to that same path we were just talking about. So of the users on the computer, we're going to go to this specific user, their desktop folder, this JepDoc folder, and then teaching and learning. So this is going to set us, on that path, and we can access all the files that are inside of teaching and learning. And so once we have that path set up, we have a working directory appropriately set up, we can now load data that's in that directory. And this is ultimately going to be the goal for this course, because we're going to have to take these files, load them in, and then merge them together. So we're going to load these files through readXL or any of the other read functions that are in this readXL package here or Tidyverse. And the reason it can be different is due to the files being different. So if we're reading an Excel file, we'll use this package. And if it's not installed in your R environment already, you can use this function here to install the package. But if not, if it's already installed, just load it in your library and you can read any Excel file in. But if it's a CSV or a text file or a data table, or you can even read in files that are SAS files or SAS. I could read in SPSS files, you name it, and there's a package out there for it. So it's really nice and flexible. So when loading these files, it's really important that you not only have the file name, but you also need to know the file extension. So if it's a CSV file, you have to use the appropriate read CSV function, and then always, add a suffix to it with the .csv to the file name. So here's an example. We're going to read this Excel file called AHQ hospital utilization, which we'll use as sample data throughout the course. And it's a .xls file, so we just have to add it in at the end. Even though we're using readXL, we always have to make sure that the file type is always included. And this is optional to use the sheet name. The default is just to read the first sheet in the workbook, but say we want to get the second sheet, we can specify what sheet we want to read in. Because here, when we're defining, when we're assigning the variable name, in this case, we just use df as standard practice. We can only assign that variable to one table. A data frame or a variable can't represent multiple tables at the same time. So we can't read in all the sheets into one variable. We just have to read them in sheet by sheet and give them names accordingly. And once that data is loaded, you'll have what's called a data frame. And that data frame is just made up of different rows and columns, very, very similar to Excel. This is just, I think this is actually in Python, not R. I should probably update this image, but here we have that hospital utilization file, loaded into our programming interface now, and we can see all the different columns and rows, and you can see all the different data types. So here we have all of the hospitals, which look like just free text, and hospital IDs. They all look like numbers. We have some missing values here for year. Otherwise, the numbers all have this decimal in it. So there's a bunch of different data types underlying. And we'll get to that next of being a really important part of the whole data merging process, because as we'll get along, you'll know that you can only join on like data types. So it's really important to understand the different types of data types, and ultimately what they consist of, different rules around them. So we'll start with character or string, which is the most common data type, I would say, because when you read files into R, whether it be an Excel file or text or whatever it is, it often just defaults to character if it doesn't have a very definitive way of saying this is definitely something else. So it'll just read all of them in as strings, which is just text, and it can basically take any type of information. As for integers, these are only whole numbers, and it'll look a little weird because you'll only see this capital L next to the number, and at times you may think, wait, why is there an L next to this number here? And it's only to let you know when looking at the data that it's an integer and not the next data type of numeric. And although you can have a numeric column or a numeric data type that is an integer, you can have decimal values as integers. Integers are only whole numbers. So that's where the numeric data type comes into play, in that it allows for decimal numbers and whole numbers if you wanted to. It could take any of them. So I don't typically use the integer data type often, but it's there. Always, I usually just default to numeric because it's just a lot easier. And logical is just true or false. This isn't used much as, in the realm of a data frame having a column full of, true or false values. It's really just used for conditional statements afterwards. So for like things like arguments in a function and stuff like that. And then factors, which are basically just, character. It'll look like a character in the row or the column, but it's in the background. It's grouped into different groups of it's really for analysis. So say we want to perform a t-test on something and we wanted to group by hospitals or something. A factor is good because it will inherently group all of them and treat the like values as one versus as a character. Each value is its own entity. So we probably won't use that much for this because we're not doing any analysis, but it's good to know for future work and stuff like that. And here's just a quick little graphic showing all the different data types. So here are your characters. As you see, they all have quotes around them. We're not going to worry about complex data types. It's not part of what we need at the scope of this class. Integers, you see these weird little L's next to it. So it's an integer, numeric, can be a whole number, but it could also be a float. And then logical, true, false. And these all make up vectors, which, think of a vector as just a list of something. But it's not as important. But once we have our data and we understand that there's these different data types, sometimes we're gonna have to change them, but before that, we'll have to check them and see, what are they? We loaded it in, we perform this read Excel function. Okay, well, what is everything? And so here, we can either check all the columns at the same time using the str function, or we can check columns individually, one at a time using the class function. So up here, you can see that data frame that we loaded in earlier, df, we could just perform the str and it'll show you this is a character and all the columns are characters, even though some like year, are definitely numeric in just looking at it and in nature, but are just defaults to, reading stuff in as characters most often. But if you just want to check zip code, we can just use we can check the class and then it'll spit out, what it is, and it's a character. And so, as we saw earlier, there's a few values in here that don't have, any information for the year. And so it's important to fill those in when you're merging because, you may have missing values that should be there, but they aren't due to, whatever reason. And we'll just have to fill those values in. So the dataplier package is really useful for that, and specifically the mutate function. And here we're just going to do a quick little case statement or conditional statement. So we're going to specify the data frame that we want as a result. So since we're just going to overwrite the same data frame, these values are going to be the same. And then we're going to use the pipe function here, which basically is just a clean way of performing multiple steps on a specific data frame, consecutively instead of in a bunch of different lines. And so the mutate function is just going to take a column. You can create a new column here, or if you want to overwrite an existing column, which is what we're going to do, you specify it first and say that's equal to, and you have a conditional statement. So if else goes logically in the sense that if this condition is true, then perform X, and if it's false, then perform Y. So the condition here is if the year column has an NA value, then we're going to perform X, which is put 2016 in there. And this is a character because as we saw earlier, the year column was, a character. So we don't want to fill NA with a different data type. It's really important to make sure you fill in the values with the same data type. And so we're going to use a character of 2016. And then if it's not true, if it's not a null value in year, then just keep the same values. And we just specify year again. And then once we have all of our values populated in that column, we can change the data type. We probably won't think of year as a character, so we're going to change it to a numeric. value. And so this is not class. This is a as numeric, or you can do as character. You can do whatever you feel is best to convert the data to, but here we're going to use the as numeric function to change this column, this year column, to a numeric value instead of a character value. Then we're just going to check it afterwards, make sure that it worked properly, and it does, because after we run class on that, it's now numeric instead of character. And to filter columns, or filter rows, I'm sorry, we can do a similar function with dataplier where we use the filter function. And filtering rows is important in data merging because it allows you to work in a more condensed space. So let's say, for example, we have a file with 3,000 rows, and we want to merge another file with 4,000 rows in it. Instead of merging everything at once and opening the door for duplicating rows and getting things a little murky, it's usually best to just filter both data frames right then and there. That way you have nice, clean, condensed data frames that when you merge, the output is also going to be clean. And so here, we're just going to filter that same hospital utilization data frame from before for all the hospitals that are in the city of Chicago. And you always want to use double equal signs on conditional statements, and then single equal signs will assign a new value to that. So before here, when we did when we mutated year, we just used a single equal sign. But when it's conditional, so where the city is equal to Chicago, we're going to use double equals. And then filtering columns. This can be done many different ways, and I want to make sure that I gave all the options instead of coercing you to use a single function or method to do so, because some people find it easier one way versus another. And so say we merge two tables and both tables have 40 rows in them, then the resulting data frame is going to have at least or at most 79 rows, because you're going to join on one common column, but the rest of the columns are unique to each data frame. So we can have a bunch of columns now, and say we don't want all of those. Say we only wanted 78 of them. We can just delete one column using the subset function, where you can specify the data frame, and then using a negative sign in front of a vector listing the columns. They don't need to be quoted here. So you can list, say we want to get rid of city and zip code, we can just list all of them here. And it's going to delete every column that's inside of these parentheses and inside of this vector. And then if we want to do the opposite, say we have out of these 79 columns, we only want to select 2 of them, we can just get rid of that negative sign, and we can just specify the columns we want to keep. And so this column will have just 2 rows or 2 columns in it. This data frame will just have 2 columns in it, that you can move forward with and export, send to somebody, whatever you need to do. But the method I find the easiest is the select function in dataplier. And here we're just going to use the same pipe, and then we can just specify all the columns that we want to keep. And it's a real quick, easy way of doing things. And then we can also use brackets, which is really familiar for people who have come from other programming backgrounds. It's typically the way to do things, but there are a lot of cool gadgets in R to make this a lot easier for you without having to get into the indexing of using brackets and stuff like that. And then once we load our data, change different data types, fill in the missing values, and filter rows and merge and things like that, we want to make sure we can export it where we want it, where we want to use it after the fact. And so we can export the data using the XLSX package, and all you have to do is just specify what data frame you want to export, and then give it a name. Again, we're going to have to keep the file type in the name, just like before when we were importing. And the sheet name is optional. It's going to default to just whatever Excel, sheet name one or sheet one, their default nomenclature. So you don't have to do that, but this is important. You always want to make sure to include this argument for column names equals true. That way, when the data gets exported, you have your column headers there, and you're not just kind of looking at a table of data with no indication of what those values indicate. Um, and so, where do you think this will export to on your computer? If your guess was to your working directory, that's true. You're correct. This is just going to export this data to your working directory. But let's say we wanted to export it somewhere else. All we'd have to do is just, we can use another path here and just put the path in front of it to export straight to that path, or we can just, change our working directory before exporting. Either would work, but this is just a quick synopsis of some of the functions and primary ways of filtering and merging or filtering data and selecting the appropriate columns to allow us to be successful in merging data subsequently. And so, later on in the week, we'll debrief and talk really quick as a group about any questions of any of this material, and I'll do a little code demonstration. And yeah, so that's it for this first asynchronous lecture, and talk to you guys soon.